All right. Today we're going to do a few questions on parametric equations and trigonometry. In the last lecture, we discussed on how we can find the area of a graph, or essentially the integral of parametric equations, and essentially the graph. So today we're going to do two questions on parametric equations and trigonometry. So here's the question. We have two parametric equations, x is equal to 4t squared and y is equal to t 5 minus 2t, and here is the graph 0, 25. This is the x-axis, this is the y-axis, and we have to find the area R. So essentially we have to find area R. Alright, that's what we got to do. Okay, so the first thing we got to remember is that the area would be given by this 0, 25 y dx, right? Because it's essentially 0 from 25. That's what the area is underneath. So, but here again, the problem is that we don't have the Cartesian equation, but we can solve it a different way, and that is what I am going to show you. Okay, so first we gotta find dx over dt, dx over dt, which is essentially the differentiated form of this equation. To find out dx over dt, x is equal to 4t squared, dx over dt is equal to 8t. 4 times 2 is 8, t squared will become t. Okay, so that is dx over dt, so dx is equal to 8t dt. Alright, now we just substitute in here 0, 25 y here's supposed to be an x, dx is equal to 8t dt, so 8t dt. Alright, the first thing we're going to do is just find the integral. Alright, we're not going to exactly come to values right about now. Okay, so now we just put the parametric version of y into here. We're not going to use the Cartesian equation, so integral t 5 minus 2t times it by 8t dt, right, is equal to integral of 8t squared 5 minus 2t dt. Alright, now just moving on to here, integral of 40t squared minus 16t cubed dt. Now we just do the integration and we'll come to this. So 40t cubed divided by 3 minus 16t to the power of 4 divided by 4, which will essentially equal 40, sorry, I think I made a little mistake over here. It should be 40 to the, oh sorry, it is right, sorry about that. 40 over 3t cubed minus 4t to the power of 4. Alright, that is essentially the answer to our integration problem. Okay, now all we gotta do is simply use this equation to find the value of R. Now what we have to remember is this, right? Okay, so we have to remember that 0 and 25 are both x coordinates. So we gotta transform these two into t coordinates. Alright? Okay then. So x is equal to 4t squared, right? You gotta remember that. X is equal to 4t squared. So 0 is equal to 4t squared, t is equal to 0. 25 is equal to 4t squared. 25 over 4 is equal to t squared. T is equal to 5 over 2, which is equal to 2.5. So essentially, we need to calculate this. We need to calculate this. 4t over 3, t to the power of 4 minus 4t to the power of 4. 0, 2.5. And that will give us our answer. Okay, so 4t over 3, 2.5 to the power of 4 minus 4, 2.5 to the power of 4 minus 0. Why? Because 0 times 0 to the power of 4 is 0 times 40 over 3 is equal to 0, and 4 times 0 to the power of 4 is equal to 0, so 0 minus 0 is equal to 0. Alright? That's really all there is to it. Alright guys, I made a little mistake over there. That was 40 over 3 t cubed, not t to the power of 4, like, you know, it appears. So eventually, when you boil that down, it simply comes down to 52, 1 over 12, and that is your answer. Alright? Alright guys, so we'll be moving on to question 2. So remember, we gotta first find out dt in terms, dx in terms of dt and t. So x is equal to 3t to the power of a half. So dx over dt will therefore be equal to 3 over 2t to the power of negative half. Alright. So dx will be equal to 3 over 2t to the power of negative half dt. Remember, the area is given by y dx. So all we gotta do is simply put this thing in place of here. Alright? So what does that boil down to? That boils down to y 3 times, of course, times 3 over 2 t to the power of negative half dt. That would mean t4 minus t times 3 over 2 t to the power of negative half dt. That would mean 3 over 2 t to the power of a half 4 minus t dt. Moving on to here, that would essentially end up being t to the power of a half, with the integral of course, 6t to the power of a half minus 3 over 2t to the power of 3 over 2. Alright. what that would essentially mean is this. So this power would increase to 3 over 2, so 2 over 3 times 6t to the power of 3 over 2 minus, this essentially would be increased by 1, so we would get 5 over 2, which is essentially 2.5, so 1.5 t to the power of 2.5 divided by 2.5. I just did it in fractions because I'm really used to having fractions, you know, for the stuff that's divisible, that is. This thing isn't divisible. So essentially that boils down to this and this cut, so you get 2, so you get 4t to the power of 3 over 2 minus 0.66 to the power of 0.6t to the power of 2.5. So that would essentially lead us to 4t 4t to the power of 1.5 minus 0.6t to the power of 2.5. Now we have the problematic thing of actually solving this whole thing. So right now we just gotta essentially translate x into t. If we remember, x is equal to 3 square root of t, so our x coordinates are 0 and 6, right? 0 and 6. Let me just draw 6 a little nicely. 0 and 6, so we know what 0 is. Now we just gotta find out 6. 6 is equal to 3 square root of t. 2 is equal to square root of t. T is equal to square root of 2. So it's going to be 4t to the power of 1.5. Sorry. Just keep clicking stupid buttons all the time. So 4t to the power of 1.5 minus 0.6 t to the power of 2.5, and here you have 0 square root of 2. Okay, now if you just do the calculation like you normally would, you would come down with this. Alright guys, I just made a small little mistake over here. I wrote t is equal to square root of 2. Actually it's not, it's 4, because if 2 is equal to square root of t, then 2 squared is equal to t, therefore t is equal to 4. T is equal to 4, and if you calculate that through the formula obtained, you'll get 2.8, which is the correct answer. Okay. Happy math.